A very good evening to all the students. Today I am going to continue with my topic of solar energy and it's part 2. I have already discussed a little bit about the importance of solar energy, the collectors, flat plate concentrating in the previous part. So from here we are going to continue with the concept of solar energy storage and its applications and solar cells. So, a very important aspect of solar energy storage lies in the function of the solar pond. A solar pond is a natural or artificial body of water for collecting and absorbing solar radiation energy and storing it as heat. Thus, a solar pond combines solar energy collection and sensible heat storage. So, what we actually do is that this is the particular schematic of the solar pond. So, this solar pond is actually consisting of three zones: Zone 1, Zone 2, and Zone 3. The Zone 1 is known as the surface convective zone or the upper convective zone, that is zero point 0.3 to zero point 0.5 meter in depth, and the salinity is less than 5%, while 2 is known as the non-convective zone, that is 1 to 1.5 meter in depth, and the salinity increases with depth, while 3 is known as the storage zone or the lower convective zone, that is 1.5 to 2 meter, and the salinity is about 20%. So, as we can see, is that a solar pond is a mass of shallow water about 1 to 2 meters deep with a large collection area which acts as a heat trap. It consists of dissolved salts to generate a stable density gradient, and this salt solution is known as brine. So, part of the solar radiation entering the pond surface is absorbed throughout the depth, and the remainder which penetrates the pond is absorbed at the black bottom, that is, bottom layer 3. If the pond is initially filled with fresh water, the lower layers would heat up, expand, and rise to the surface. Because of the convective mixing and the heat loss at the surface, only a small temperature rise in the pond can be obtained. On the other hand, convection can be eliminated by initially creating a sufficiently strong salt concentration gradient. In this case, the thermal expansion in the hotter lower layers is insufficient to destabilize the pond. So what we do is that we make a salt solution and the salinity increases with depth. And because of the saline solution or the brine solution, the heat is trapped. And as we can see is that this is the plot of depth, the plot of salt by weight, and the plot of temperature. So we can see that the concentration of the salt increases with depth and so the temperature so that we can trap the heat. Now, the application of the solar pond is in using a solar pond power plant. So, as we can see that this the solar pond is there. So, in the previous slide, we can see that this is the return brine and this is the hot brine. So, here also this solar pond hot brine is utilized in a heat exchanger, and the cold brine is returned back as back of the refrigerant liquid, and from the heat exchanger this is the pump, and the refrigerant vapor is going, it is running a turbine is connected to the generator, and some amount of condenser can return the water back to the cold brine system. So the hot brine solution from the bottom of the solar pond is taken out without disturbing the brine gradient. The solution is taken to the heat exchanger to remove the heat from the brine solution by evaporating a refrigerant in the evaporator. These vapors are used to run a turbine which is coupled to a generator to generate power. The refrigerant vapors that are exiting from the outlet of the turbine are further condensed to liquid state in a condenser and pumped back again to the heat exchanger. So that is the complete schematic. Now moving on to the other applications of solar energy storage, that is the solar stave. So this is the basic schematic of the solar cell. The process to convert saline water into pure water using solar radiation is known as solar distillation or solar still. A solar device used for this purpose is known as the solar still. So solar still is mainly helpful for solar distillation. A solar still is consisting of a shallow blackened basin filled with saline or brackish water that is to be distilled. It is covered with a sloping transparent roof, that is the transparent sloping roof. The sun rays can pass through the transparent roof, and these rays are absorbed by the blackened surface of the basin. So, this is the blackened surface of the basin, thereby increasing the temperature of the water. The water in the basin evaporates due to the solar heat and rises to the roof. The water vapor is cooling down and it is condensing at the undersurface of the roof. The water drops of the condensed water slip down along the sloping roof. So this is the condensed channel that is slipping down. Okay. And the condensed water is collected at the condenser channel and drained out from the solar still. So this is what the distilled water, and this distilled water is drained down. And this portion is known as the basin. Okay, and it is filled up with the saline water, and that is the black bottom. So this is the concept of the solar still that is used for solar distillation. Now moving on to the concept of solar cooker. This is also a very important application. It is a box type solar cooker. So it consists of an insulated block that is made up of blackened aluminium, in which the utensils with food material are kept. And there is a reflector mirror, as we can see that this is the reflector mirror. So this reflector mirror is used, and it is hinged to one of the side of the box so that the angle of the reflector can be adjusted. And also there are glass covers consisting of two layers of clear window glass sheets, which also serve as the box door. So this is the glass cover. The box is kept in such a way that the solar radiation falls directly onto the glass cover, and the reflector mirror is also adjusted in such a way that the additional solar radiation after the mirror reflection is also incident on the glass cover. So the glass cover is trapping the heat owing to greenhouse effect. That is, what happens is that the short wavelength radiation can pass inside the box, but the long wavelength radiation coming out from the box is also entrapped inside, thereby providing more heating effect. The air temperature obtained inside the box, it ranges from 140 to 160 degrees Celsius, and this helps in cooking the food and boiling the food, and helping in our cooking purpose if we can use a solar cooker. So this is small box type cooker